Okay, library of functions. So 3.3 is where library of functions, where I got this information. So this is just kind of for your toolkit so that you are familiar with how each of our functions graph, okay, and increasing, decreasing, that kind of thing. So grab my little highlighter here and let's get started. So with the cubic function, it is increasing always. It goes from negative infinity to positive infinity. It graphs, well, like that, okay? This should go pretty quickly on this one. Reciprocal, it is decreasing from negative infinity to 0, and then we make a jump and it goes from 0 to infinity, so it graphs like this. Our reciprocal squared, it's increasing from negative infinity to 0. So we go from negative infinity to 0, it's increasing, and then it's decreasing from 0 to positive infinity. Our constant function, well, that is just like always a straight line, right? So it's neither increasing or decreasing because it's just, well, straight. The identity function, this is when your y equals x or your f of x equals x, and it's always increasing. It goes like this. And the identity is because when x is 1, y is 1. X is 2, y is 2. It's kind of cool function. Quadratic. Oh, I haven't been underlining these. I'm sorry. I get excited about math and forget to do what I'm supposed to be doing. So quadratic function. Oh, here we go. Give me a minute to get back where it was. I'm sorry. I don't know why it does that. I'm still trying to decide. So the quadratic function, when y equals x squared, it's increasing from 0 to positive infinity. If I could get my little guy to follow me over here. So on this side, what's not playing well with others today. So this side, on the right hand side of the y-axis, it is increasing. On the left hand side, it is not. It is decreasing from negative infinity to 0. Okay, I'm gonna exit off of this so I could change pages. All right, back with our little highlighter. The cube root is always increasing. It goes from negative infinity to positive infinity, okay? Square root, it's increasing from 0 to positive infinity. That's how it always graphs. And then the absolute value, he's increasing from 0 to positive infinity, and then he's decreasing from negative infinity to 0. And absolute value always graphs either like a B or like a A if it's got a negative coefficient. Okay, so that's our absolute value. Let's see, how far are we? 3 minutes. Yeah, I think we can make this whole little lesson in one video. So we're going to try really hard. So now let's talk about piecewise function. This came highlighted, so I just left it that way for you guys. A piecewise function is a function in which more than one formula is used to define the output, okay? So each function has its own domain, and the domain of the function is the union of all of these smaller domains. That sounds really complicated, right? So for formula 1, we have this domain, right? X has to be within this said domain. Formula 2 has its own domain, which its x has to lie within it. And then formula 3, x has yet another domain, and it has to lie within it. So an easier definition that I like better, my little simple speak down here, is a function, piecewise function is a function that is defined by 2 or more equations over a specific domain. Okay, that is your piecewise function. I like that one. It seems easier to me. So a cool piecewise function that we use a lot is our absolute value. And that, so if x is positive, if x is greater than or equal to 0. But x is negative if x is less than 0. So that's our piecewise function for the absolute value. And I just thought that was cool, so I wanted you guys to see that, okay? You're going to learn in this class. What I think is cool, you guys have to look at. I'll apologize for that now because I think a lot of things in math are pretty cool. So let's go up. So here are some piecewise functions. A lot of internet plans or cell phone plans use piecewise functions. So I made a problem, or I didn't make it. No, I didn't make it. I chose a problem that is based on data. So, cell phone company offers the following mobile hotspot. $40 a month includes 15 gigabytes of data, okay? Additional data costs 60 cents per gigabyte. So we can represent this plan mathematically by writing the total monthly cost, C, as a function of the amount of data used, which is G. So here is our piecewise function, right? C of G, you pay $40 if you stay within your plan, right? That's what it says. Or if you go over your plan, then you have to pay the $40 plus 60 cents for every gigabyte over the 15. So that's if it's over 15. So we're going to figure, that's not very good, sorry. Use the following function to find and interpret each of the following. So first we're going to find C of 10. So our amount that we used, our gigabytes, were 10 gigabytes. So all you do with the piecewise function is you look and you see the number that you're using, what your x equals. Well, in this case it's G, but what your x equals, and you come over here and you look at your domain that it's given you. So is 10 between 0 and 15? Well, it is. So since 10 falls into this domain, we're going to use this function. So for A, C of 10, well, it's just going to equal 40, right? Because it falls within this domain. Now let's do another one. It's not that hard, right? Now we're looking for C of 45. So we're like, does 45 fall within this range? No, it doesn't. So we jump to the next one. Is 45 greater than 15? Well, yes, it is. So C of 45, since it falls in this range, then we're going to use this function. So anywhere there's a G, we're now plugging 45 in for our G. So it's going to be 40 plus 0 point, that's a point, sorry. There's my phone. That's bad form, isn't it? And then we're going to have 45 here. If you'll let me put my pen down for a minute, I'll turn off my phone. I'm so sorry. Okay. I apologize again. Okay. So now we have, all we got to do is just do the math now. If you have a calculator, you can skip through all these steps. I'm going to work them just so that we have them, but this is going to be 40 plus 0, make a big point, 60 times 30. So 40 plus 18, which gives us, if we go over our plan, right, which was 15, and we go over it to 45, we're going to spend $58. Okay, that's all that a piecewise function is. You just look and see where this number falls. If it falls within this one, you use that function. If it fell in with this one, you use that function. That's truly how simple they are. It's one of the easiest problems you'll do in college algebra, okay? Let's do, ooh, hello friend. Let's do another one. Okay. So this one, we have f of -3 for A. So which one does it fall into? Is -3 less than 0? Yes, it is. So we're going to use this one. So anywhere there's an x, we're going to plug in -3. So 6 times -3 minus 1. Well, 6 times -3 is what? -18 minus 1 gives me a -19. Okay, that's our answer for A. Everybody cool with this, I hope? B. Now we have f of 0. So is 0 less than 0? No, it is not. Is 0 greater than or equal to 0? Well, yes, it is. So we're going to use this function. So 7 times 0 plus 3. Well, 7 times 0 is 0 plus 3 equals 3. I'm not really kidding when I say it's pretty simple, right? And then C. Why did I write 7? My goodness gracious. F of 4. Now, is 4 greater than or equal to 0? Yes, it is. So 7 times 4 plus 3. 7 times 4, 28, plus 3, 31. Okay, y'all can handle those, I think. Pretty simple. Now let's talk last about graphing a piecewise function, okay? Ooh, snap. Easy on the finger, Shirley. There we go. All right, graphing a piecewise function. And this tells us how to do it. I know you guys can read this, but this is where I get paid the big bucks, so I'm going to do it. So first thing we're going to do is we're going to indicate on the x-axis the boundaries that each interval is going to use, okay? And then once we do that for each piece of the domain, we're going to graph the interval using the corresponding equation, okay? Do not graph two functions over the same interval because that just kind of breaks all the rules, okay? And it's going to make for a really, really messy graph. So I'm going to use different colors because that's kind of my thing. I love different colors. So let's do, I don't know. Let's do pink for x squared. Let's do, I don't have that many colors. Purple for 3. And let's do green for x. If you're wondering if I do this many colors in class, yeah, I do. I do more. I have a lot of colored pens. Okay, so for our x squared, I'm going to go over here. X squared is pink. If I could find my pink color. There we go. So for x squared, we know it is less than 1, less than or equal to 1, right? So I'm going to make me a little x squared, and that's going to equal y, right? So it's going to be equal to or less than 1. So if we have a 1, a 0, a -1, and a -2, that's a pretty good representation, right? And each of these are going to be squared. Well, 1 squared is 1, 0 squared, 0, -1 squared is going to be 1, and then -2 squared is going to give us 4. So that's what we're going to graph on this, but it has to be less than 1. So where we're going to graph that is from here over. So and it says less than or equal to, so we know it's going to be a filled in dot, right? So it's going to go that way. So from here to here, and then we're going to have a 1. And then a 4. That was 2, right? -2, 4. Wow, didn't mean to do that. I'm going to take off way up here. That's going to be 4. Okay, so that's going to be our parabola for that guy, right? So we could just go ahead and draw him if you want to. And try to do a really good job, but it's really hard on this. There we go. So that is this guy done. Now we know that our 3 is going to be between 1 and 2, and he's going to be purple. And that's not really hard to do. It's going to be y equals 3, and he's going to be right up here at 3, 1, 2, 3, and it's going to be from 1 to 2. And this side is an open circle, and this side is a closed circle. Cool. Just from our little lines that we know that. And then now our last one, our x, we know he is greater than 2. So at 2, we're going to start our x equals y. So if he is 2, this one's going to be 2, right? Ooh, switch colors, Shelly, about blew that one out. That's the ugliest green. Okay, so this is the identity, right? Y equals x. So if this guy's 2, he's going to be 2. Oh, stop already. So he's going to go from here, which is an open circle, and then it's just going to go on that way. So if he's 3, if x is 3, y is 3. So it's just going to be a straight line through each of these points, and it's going to go on forever. So that would be how we would graph that, right? Because it went from 2 onto infinity. And we could also do our t chart over here if you wanted to for your x and your y, because you know he started at 2, and since it's identity 3, 4, I don't know, 5, let's just go to 5, then it would be the same. So you could do it either way. Just know that identity graphs that way because we did the library, or you could do a t-chart, okay? Or an XY chart, whatever you guys call it prior in high school, okay? Right on, that's it. Short little video for this one to make up for all the ones we had on the very first lesson. Okay, I hope you guys have the most blessed day.